they're asking me to state if the number is rational, irrational, or not a real number. So remember, rational is anything we can write as a fraction. Irrational is things we cannot write as a fraction, like a repeating decimal that doesn't have a pattern. Real number isn't really going to fit into any of those ideas here. So as we look at the concept of 0 over 3 in question A there, 0 divided by 3 makes 0. Can we write that as a fraction? Well, it was already written as a fraction, and of course you can write 0 as a fraction any way you want when we go ahead and put 0 over a number. Can't do it the other way. We can't put 0 on the bottom. That's something that doesn't exist. But if 0 is in the numerator, that's not a problem. So since I can write it as a fraction, that's rational. Now in B, they're asking me to take the square root of a negative number. Remember, as we said earlier, there is no number that I can multiply by itself to make a negative. So there's nothing that's going to exist here that I can take the square root of to make a negative. So in that particular question, that's not going to be a real number at all. It's not rational, it's not irrational, it's not real. It doesn't even really exist except in this concept of imaginary numbers, which you'll see later on in your mathematical careers. In C, we've got the square root of 4 over 9. Remember, you can take those and separate them and write it as the square root of 4 over the square root of 9. Well, those are both perfect square roots. Square root of 4 is 2, square root of 9 is 3, so this is the same as 2/3. Well, 2/3 is a fraction. Since it is a fraction, that does make it rational. So here you're going to say rational because it is something that can be written as a fraction. Again, irrational is going to pop up if you had something that equated to a repeating decimal, something that went on and on forever, but didn't have a pattern to that repetition. That would cause it to be irrational. So if you have something on your calculator and you're in question, divide it out or do whatever you need to do. If it goes on and on forever and does not have a pattern, that's going to make it be irrational. Now in question number 3, what they're talking about is that density property that they defined earlier. Not density in terms of science, but they're talking about the ability to find a number that is between any two rational numbers. So here they're asking me to find a number that's between 3 2/5 and 3 3/5. And of course, one of the best ways that you can find something that's between two numbers, which is what they're doing here, is they're actually averaging those two numbers, finding the mean of those two numbers. Of course, that implies what they're doing here is they're going to add those two numbers up and then divide by 2, which is what you can see they're doing here. So they've got 3 2/5 and 3 3/5, and they're going to start off and add those together. 3 and 3 goes together to make 6. 2/5 and 3/5 makes 5/5, which is what you can see right here. Of course, we can rewrite this as 7 because this would be the 6 plus 5/5, which makes a whole 1. 6 and 1 goes together to make 7. And then I'm going to divide that by 2, and that's going to give me 3.5. Perhaps if you're doing that on a calculator, you'd see 3.5. But as you know, that's 3.5. So 3.5 has to be between 3 2/5 and 3 3/5. Now, if you're still having a little bit of a hard time seeing that, go for common denominators, and it will be easier to see. With 3 2/5 and 3 3/5, having said based on the calculation that we just did that 3.5 should be in between, and in this particular case not just in between but perfectly halfway in between, again, go for that common denominator. Looking at those denominators, the common denominator of 5 and 2 is going to equate to a 10. So if I make these go to 10s here, with the 5s as the denominators, we're multiplying by 2 there, because that's how I'm going to make that 5 go into a 10. Remember, you do the same thing to the numerator there. So then that's going to change into 4 and 6. Looking at this particular question, to go 2 into 10, we're multiplying by 5, so I'm going to do the same thing into the numerator there, and there's 5/10. Well, of course, you've got 3 and 4/10, 3 and 6/10, 3 and 5/10 logically is in the middle, and that's helping us see 3.5 being stuck in between 3 2/5 and 3 3/5. And again, that's us talking about the density property as defined, which simply says there has to be a number in between two real numbers or two rational numbers if we want to talk about this particular question. All right, so let's go ahead and take a look at the concluding examples here in the Check It Out. Number 1 is asking me to write all the names that apply to the number. So then the question is the square root of 9. Well, the square root of 9 is, of course, equal to 3. So if we go back and look at that chart that's on page 195 that we've referenced a bunch of times, as you can see, that's actually listed here in the natural numbers, so it's going to fit everything that encapsulates that bubble. So it will also be a whole number and an integer and a rational number. And remember, no matter where it fits on that chart, it's also going to be a real number. The only thing it's not going to be is irrational, because that's off on a category on its own. So as you can see, they've listed there as the solution: natural, whole, integer, rational, and real. Number 2, final problem here is asking me to state if the number is rational, irrational, or not a real number. Well, as you can see, once again, the example we've quoted so many times in this presentation, they're asking me to take the square root of a negative number. Once again, there is no number I can multiply by itself that will generate negative 7. There's no number I can multiply by itself that will make any negative number. And because that number does not exist, that means it's not a real number.